Hi everybody. Um, so I hope you're all well. This is going to be my first example from section 4.3, where we're solving homogeneous equations. Um, and so the first example I'd like to solve is y triple prime, so that's the third derivative of y, minus 5 times the second derivative of y, plus 4 times the first derivative of y, minus 20y equals 0. So we're assuming y is a function of x here. So first thing we should do, of course, is figure out the auxiliary equation. Again, if you watched the Khan videos, he calls it the characteristic equation. Same thing as the auxiliary equation. So the auxiliary equation, so I'm going to use m as the book does. So this is m to the 3 minus 5m squared plus 4m minus 20 equals 0. So this is since this is a third order differential equation, this is a third degree differential equation. And you can basically solve it any way you want. You can use your calculator, for example, to get one of the solutions, the real solution. I'm just going to factor by grouping, so I'm going to factor out the m squared from the first two terms, leaving us with m minus 5 for the other factor, and then factor out the positive 4, leaving you with another m minus 5. All right, so now we can factor out the m minus 5. M minus 5. And then the other factor would be m squared plus 4. So when you solve m minus 5 equals 0, you get m is equal to 5. And when you solve m squared plus 4 equals 0, you get m is equal to plus or minus 2 times I. Sorry, that's an I. Right. And so, these are the solutions to the auxiliary or characteristic equation. And so that gives us the solutions to the original differential equation for y. Remember, this is going to be e to the 5x. Yep, so the first linearly independent solution will be e to the 5x. And then the second one, well, you can do e to the 2ix. And then the third one would be e to the negative 2ix. But remember, we can convert these to sines and cosines. So this is really just cosine of 2x and sine of 2x. So these are the three linearly independent solutions. Now we just combine them all, form a linear combination. So this will be c1 e to the 5x plus c2 cosine of 2x plus c3 plus c3 sine of 2x. And that should do it. So, any questions? You can always ask me questions by email, I suppose. Right, so that's the first example. I guess I'll try one more, and I'll make it an initial value problem. So, let's see. So this will be example 2. So suppose we want to solve, let's do y double prime plus 6y prime plus 9y equals 0, with the initial condition that y of 0 is equal to 1 and y prime of 0 is also equal to 1. Okay, so hang on. Okay, so the first thing we should do is, again, solve the auxiliary equation, m squared plus xm plus 9 equals 0. And so here we get a double root, right? So m plus 3 squared equals 0, which means we only get one unique solution. M is equal to -3. So remember what we do in that case. So obviously one of the solutions, y1, will just be e to the -3x. So to get the other linearly independent solution, we're just going to multiply by x. So x e to the -3x. Okay, so that means the general solution is going to be y, I should put of x, y of x, is equal to c1 e to the -3x plus c2 times x times e to the -3x. Okay. Now, to get the specific or particular solution, we use the initial conditions here. So if we were, well, first let's take the derivative, y prime. So that's going to be -3 c1 e to the -3x. And here we have to use the product rule, right? So first times the derivative of the second. So that's going to be -3 times c2 x e to the -3x plus second times the derivative of the first. So that's just going to be c2 e to the -3x. And so I think we can simplify this a little bit. So obviously we can take out the e to the -3x. That just multiplies everything. So we get -3 c1 plus c2. Oops. And then minus 3 c2x. Okay. Yeah, so now let's just plug in y equals 0 here. Down. So if x is 0, we just get c1 plus 0, right? So that tells me right away that c1 has to be 1. Now, when we plug 0 into the derivative, we get e to the 0, which is 1. And then we get -3 c1 plus c2 minus 3 c2 times 0, which is just -3 c1 plus c2. But remember, we already know that c1 is 1, so this is just -3 times 1 plus c2, and that has to be equal to 1. Right? So that tells me that c2 has to be, positive 4, right? 1 plus 3 is 4. Okay, so that should give us our final answer. Squeeze it in over here. So y of x is just going to be c1, which is 1, so e to the -3x, and then plus 4 times x times e to the -3x. Or if you prefer, you can factor out the e to the -3x and write it as 1 plus 4x times e to the -3x. Either way is fine. So, any questions on that? Again, you can send me emails if you have any questions on anything here.